Bismillahirrahmanirrahim. So, what I want to stress is that statistics is a branch of rhetoric. Rhetoric is just how to make arguments, how to convince people. Now, for a while in the West, they have believed that there is such a thing as fact and opinion, and these two are clearly separated. Opinions are subjective and not very reliable, and not very important and not part of knowledge. And facts are solid, reliable, indisputable. There is no possibility of arguing about them. This idea that there is a clear separation between objective knowledge and subjective knowledge, this is widely believed, and this idea is completely wrong. There is no such strong separation. Every fact has some element of subjectivity in it, and there are many subjective opinions which have a lot of factual content. So, you cannot separate the two. So, once you realize that, because of this separation, then in the West, when they make arguments, they use statistics, and the impression is given that this is absolute, final, objective, when in fact, almost all statistics that we use are highly arbitrary, subjective. They have lots of places where you can hide opinions and you can hide biases and you can hide. And because in the West the idea of knowledge is that you should not have an opinion, so they are forced to this bad methodology, that they are forced to hide opinions inside what looks like numbers. So now this lecture is about how mean, median and mode are used in arguments and how they should be used. I mean, it's not that we are rejecting the use of facts or numbers, it's just that we want to use facts and numbers intelligently. Understand that facts and numbers by themselves are not anything. You have to put some subjective input into them in order to get something out. Facts and numbers by themselves do not make an argument. And there are no completely concrete and objective arguments. So this is basically... So what this lecture is about and how it goes beyond the typical statistics lecture is that it explores why do we use these numbers, why do we want to find out the mean or the median of the data, why? So the very first thing is that it is because of our mental constraints. If we actually can understand a full data set and hold it in our memory like computers can, then there is no need for mean because I know all the numbers. But because our mental capacity is limited and we cannot understand a list of 1,000 numbers directly, so we have to reduce it to something we can understand. So automatically, when we reduce 1,000 numbers to one number, automatically we will lose information. So it's not possible for us to reduce a large number to one number without loss of information. So always some information is given, yani when you take the average, however you take it, whether you take mean or median or mode, and there are other ways also. That will be one number which is supposed to be representative of the data. But obviously one number cannot represent data. There will be lots of aspects and angles and information in the data which are not captured. So you have to keep your eye on both of the things, what was captured and was not captured. And very often deception is carried out by concealing something. So there are two very well-known examples where both mean and median are misleading. One is the case of bimodal distributions. When you have bimodal distributions, this means basically that you have two different populations. So in the GNP per capita example, basically there are rich countries and poor countries, and they are quite well separated from each other. So if you take the middle is where nothing is. There's a group of poor countries, you can talk about what these are like and what their average is. There's a group of rich countries, they have their own mean and average and distribution. And then there's the middle where there's nothing. So the middle is what you will get by mean and median, which will not be very meaningful. It doesn't represent the data, it doesn't really actually do anything for you. So the mean or the average, the standard measure which is used in all statistics courses, is obtained by pooling all the resources and dividing equally. If you just pool all the numbers and you divide them equally, then you will get the average. So this will be representative if more or less there is even distribution, then the mean is a useful one number summary of the data. If the distribution is not very equal, then it's not very representative. So can someone give me examples of situations where the mean would not be a good number to use, other than the bimodal case which we discussed?
The salary of a nation.
The salary, the incomes. Why is that not? That is a correct example. Salaries or incomes, if you look at the highest data, you find that the average is not. Why is it not representative?
Because there are lots of outliers.
Because there are few outliers. What happens when there is outliers?
Sir, it do not represent correct. It do not become a correct representative of.
Sir, they pull the mean up, and
yes,
do not actually depict the right average of.
Right. I gave a specific example, I think, in this lecture, which is real data from some place where there was an outlier. अच्छा इसमें नहीं है. There was a small town in somewhere where the highest sample was done. So one of the people was a millionaire and the other people had incomes of 1,000 or so, and there is a small sample. So if you take the average, you will get something in the thousands, 20,000. Now this 20,000 is sort of a meaningless number. यानी एक millionaire है, he is, उसका कोई मुकाबला नहीं है 20,000 से. And then there are these poor families which have incomes are in the range of 10,000. So again, 20,000 is not. So when you say that our average person earns 20,000, this is a meaningless statement. So this is what I am saying, that on the other hand, you can say, if you want to argue 20,000, and sometimes you want to do that, you say you want to deceive people. You say, okay, people are very well off, they are earning 20,000 rupees on the average. And why? Well, I took a random sample, which is very good, and then I took all the incomes and I took the average. Nobody will be able to see anything wrong with this. See? And you say, yes, fine, this means the income is 20,000. It is like this story which is told that there was this man who was a statistician. He took different random measures of the river's depth, and he said, okay, the average depth of the river is only 3 feet, so we can cross. So he took his family and they crossed over and they all drowned. Because the average was 3, but at some point it was 7 feet deep, and at the point it was 1 foot. So the average is not a representative in this situation. इसका कोई शेर भी है उर्दू में के वो सारे नंबर चूके तू मेरा कुंबा डूबा क्यों. So this means that the representative now, for example, there is a book which is called How to Lie with Statistics, and it gives several examples where the average is misused. So, for example, one of the examples in that book is that Yale University wanted to establish that graduates of Yale earn a lot of money, so as to advertise their own university. So this was sometime in the 60s or 70s, I think. So what they did was they found out, they called up some of their alumni whom they could trace from 20 years ago, and they find out what their income was. They telephoned and they called, and they wrote it down, and they took the average. Okay, we took a survey of those alumni that we could trace, and the average in this sample was a large number of dollars per year, which was much larger than the national income. So they said, okay, our graduates earn a huge amount. So now can somebody tell me why this is very likely not a good procedure and not representative? Why it is being used in the examples of how to lie with statistics? What are some of the reasons why this average might not be very useful or meaningful?
So as we are calculating GDP, national income.
मैंने अभी GDP की बात नहीं आ रही, ये ग्रेजुएट्स की पर्सनल इनकम की बात कर रही है. ग्रेजुएट्स ऑफ येल यूनिवर्सिटी, उनको टेलीफोन पे हमने ढूंढा 20 साल के बाद, यानी 20 साल के ग्रेजुएट, और फिर उनको उनकी इनकम्स हमने कैलकुलेट की.
सर नंबर गलती से किसी और का भी लग सकता है
नहीं, ये तो खैर दिस इज नॉट, यानी वी अस्यूम के देवर एक्यूरेटली यानी रिटन डाउन. ये गलती तो हो सकती है, मगर दैट्स नॉट अ रीजन व्हाई द एवरेज माइट बी रॉन्ग. इसमें 3-4 रीजंस हो सकते हैं व्हाई. हमने कंपेयर किया नेशनल इनकम से, तो बहुत से रीजन हैं जिसकी वजह से ये कंपैरिजन जो है ये फेयर नहीं है, बायस्ड है.
तो उसमें तो फिर वो मिलेनियर्स भी आ जाएंगे नेशनल इनकम में, और वो जो दूसरे हैं उनमें से हो सकता है कोई भी ना हो.
अगर उस सैंपल में आउटलायर्स हों तब तो ये हो सकता है. अगर
हर कंपनी या फर्म्स की सैलरी पैटर्न डिफरेंट होता है, डिफरेंट होती है कि एक दूसरे से मैच नहीं करती, स्किल्स में डिफरेंस आ जाता है एजुकेशन.
That would not cause a bias in this, because यानी you take your graduates वो किसी भी कंपनी में हो सकते हैं, इसलिए. अच्छा, ये बतलाओ कि हम लोग 20 साल के बाद we are trying to trace some people. So what kind of people will be able to trace and what kind of people will we not be able to find? Kya? Age? Age is another factor. That's a separate issue. That's another source of bias. Average population में ज़्यादातर लोग will be young can start career, जो senior professionals हैं वो थोड़े होंगे. So if you take only graduates which were 20 years ago and you compare with the national average, तो obviously जो benchmark है उसमें हर किस्म के लोग हैं. You should be comparing with people who are late career professionals. तो benchmark गलत है. Age के एतबार से बात सही है. मगर there's another factor which I was trying to point out, which was that basically if you are tracing people, जो लोग मशहूर हैं वो तो trace हो जाएंगे, जो गुमनाम हैं वो नहीं trace होंगे. So the people who are well known, rich, famous, and their telephones and they are listed in directories, you will be able to find them. And those people who didn't do very well and dropped out and are obscure and unknown, they will not be traceable. So most likely if you're just, because basically this is the issue of random sampling. What you need to do is that if you take all your graduates and you have to have a representative sample, but if you just try to trace people, this will not give you a representative sample. You will pick the best. Third factor is that people might lie about their incomes also. Often happens that people exaggerate what they earn. So these are just some of the factors, and there are others as well. So when you take
इसका कंपैरिजन मतलब कि अगर कोई शख्स अपनी सैलरी के बारे में या वो ग्रेजुएट्स अपनी सैलरी के बारे में सही नहीं बता रहे, तो सर उसका हम जीडीपी के साथ क्यों नहीं कंपैरिजन कर सकते?
जीडीपी के साथ
सर आप नेशनल इनकम के साथ आप सर नहीं कह?
नहीं, we are just looking we're looking at average income as a benchmark, and we are comparing it with the income of Yale graduates. So, if the national income is also obtained by the same method and there is the same possibility of lying, then it becomes comparable, yes. But if the national income is obtained from tax records, then actually the bias will go the other way and people will be concealing incomes on their tax records, so rather than reporting it. So that could be another source of bias. अच्छा, so the mean gets distorted by outliers. तो यहाँ पे this is a different factor. यहाँ जो household size है इसमें there are not huge outliers. देखो, there is a terminology which is called the black swan. Black swan is a extremely unusual outlier. I think I explained the idea once that it's something completely unexpected. तो यानी household sizes में अगर ज़्यादातर जो है वो 5, 10, 15 हैं और एक 1000 का है तो फिर that's a black swan. But we don't expect to see that kind of an outlier in household size. Financials में आ जाते हैं इस किस्म के outliers financial data में, and there are other kinds of data like earthquake data and floods and storms. इसमें बहुत huge outliers आ जाते हैं, मगर ये household size में we don't expect to see big outliers. Though there is unusual, यानी मैंने जब ये highest income data देखा तो I think the largest household size were around 30 or so. So that's pretty big, but it's not a black swan. So when you calculate, yani some households have only 2 people, some have only 1. Average household, अगर हम mean लें, so it comes out to 5.67. So now, if you think of it as a representative, ये तो बहुत ही odd number है. So you could say कि representative is 5 or 6 if you want to say 5 or 6. that would be representative. And these are numbers are used by builders. आप एक घर बना रहे हैं, and you want to know how many bedrooms to put in it. So you want to know what your average household is, so that you can build a house which will be useful for most families. They want to purchase. If you build one house less than the average family, then your market will be reduced. People who have larger families will not want to buy your house because they say it will not accommodate the family. Yes.
Sir, one question. Sir, अभी आपने कहा कि a family of 30 would not be a black swan. Sir, but given an average of 5 around, why not?
Oh, this is just terminology. It's black swan in the sense it's extremely unexpected. But the discrepancy between 15 and 30 is only a factor of 2. And black swans जो है वो हम उसका देते हैं जब उसका factor जो है वो बहुत ज़्यादा high हो. It's just terminology. But if you think about how much of a surprise it is, it's a black swan in that sense. Yes. But black swans जब हम इस्तेमाल करते हैं तो numerically they cause much more damage. They completely destroy any analysis possibility. हालांकि ये 30 वाला it will just come in the average. It won't actually distort the average क्योंकि इतने सारे households जिसमें 30 आ गया तो उसका वो 5.6 and it won't actually change the average very much to have a few. So now representing का काम तो ये नहीं करता है, मगर benchmarking is a standard for comparisons. तो benchmarking का काम ये कर सकता है. This is represent. If you say you have a family of 6, then that means your family size is bigger than average. And if you have a family of 5, then it's less than average. So it's reasonable. And if you want to have a standard for comparison, this is one possibility. The question is, why are you comparing? बहुत सारी चीजें हैं इसमें where comparisons are used in arguments, and so you have to think about what the argument is making up. हम लोग मसलन बर्थ कंट्रोल या फैमिली प्लानिंग के लिए कर रहे हैं मनसूबाबंदी, तो we can say कि well you try to have smaller than average size, and average size is this, so we are trying to pull the average down. So that's what we should target for. So this is one way, and there are many other possibilities for how to use this information. Anyway, the point is that 5.67 is just one possibility. अब यहाँ पे जो है ये, this is actual data I think from this is actual data of Atak. Atak में तो बहुत सारी families हैं, but this is a random sample of 127 households. So one of the important things about a random sample is that it is representative normally. So if we get information out of this, it should be applicable to Atak. In fact, this is one of the things that is very important to study in a statistics course. Okay? How well does the sample match the population? In fact, this is the fundamental question of statistics. Okay? We take a random sample and then we can do calculation. Like if you want to determine what is the household size in Pakistan, that's pretty impossible to find, in the sense that you have to go to all of the millions of households and measure them all. It's a very expensive proposition. पिछले 20-25 साल से census नहीं किया गया क्योंकि it's so expensive to do, and also because of its political implications. So instead of doing a full census, what you can do is take a random sample.
Survey में we can take a short surveys in like.
हाँ, अब जो आप लोग रिसर्च में सर्वे करते हैं, they are not very good actually, क्योंकि what you do is what is called sample of convenience. You just sample whoever you can find and whoever is ready to sit and answer your question, and that is completely bogus in the sense that it is not representative It is just, it can change very much. The random sample is very carefully constructed. You have to take the whole population, and then everyone has to get an equal chance of being in your sample. And then if you do it, then it can be representative. So here, this was done by the Federal Bureau of Statistics, who knows about random sampling. So first thing you have to do in random samples is to construct a frame. Your frame actually gives you the whole population. You have to have all of it before you, and then you pick at random few people from there. If you just go out on the street and say, okay, I'll meet the next person, and whoever is walking, I'll take interviews of 100 people. So that doesn't work. That's not a random sample, because everybody doesn't have an equal chance. तो अब इसकी हमने काउंट्स कर ली और उसको अरेंज कर दिया, and now the median is the place where half are below and half are above. यहाँ पे this is the histogram which shows you कि कितने families के क्या numbers हैं. तो you can see that this is a is this a bimodal distribution? Yes, this is bimodal. What is a mode? How do you? 7 is one of the modes and 5 is the other mode. So how do we know that this is a mode?
Highest or most frequent.
नहीं, there is another mode.
Yes,
वो highest नहीं.
22. Because adjacent figures are less than 20, then 20 is another mode.
सही है, because 7 is high and 6 and 8 are low, and similarly 5 is high and 4 and 6 are low. So this
highest peak होता है उसको भी तो ऐसा मोड लिया जाता है.
Highest peak is the mode, yes. मगर a mode is a local maximum, यानी highest peak is automatically, यानी एक होता है local, एक होता है global. Local means के nearby, in that neighborhood it's a maximum, and global means it's a maximum for everything. So every global maximum is automatically a local maximum. So the highest peak is automatically a mode, but there can also be other modes in the data.
So then here 7 will be the global mode.
क्या चीज?
So 7 will be the global mode as well.
हाँ, 7 is the global maximum. मोड की जब बात करते हैं तो उसमें ग्लोबल नहीं कहते हैं. मोड जस्ट मीन्स लोकल मैक्सिमम. दिस इज द ग्लोबल मैक्सिमम.
Sir, actually I was confused while understanding the difference between in fact representative and benchmark. It was not very clear to me somehow.
Okay, so
सर ये जो मोड की बात करते हैं तो हम सर ये कहते हैं कि द मोस्ट फ्रीक्वेंट वैल्यू. तो सर उसमें तो डाटा में यही हो सकता है कि एक ही मोस्ट फ्रीक्वेंट वैल्यू होगी, या उसके मतलब अगर 7 जो है 7 नंबर ऑफ जो
ये तुम लोगों को बच्चों को बतलाते हैं बात, जैसे कहते हैं कि बड़े नंबर से छोटा नंबर सब्ट्रैक्ट नहीं कर सकते हैं, मगर बाद में जब बड़े हो जाते हैं तो उनको बतलाते हैं नेगेटिव नंबर्स भी होते हैं. इसी तरह से ये मोस्ट फ्रीक्वेंट वैल्यू ये बच्चों को बताने की बातें हैं. जो रियल डेफिनेशन ऑफ मोड है वो ये है कि इट्स अ लोकल मैक्सिमम. अच्छा, तो दूसरा सवाल क्या था यहाँ पे? हाँ, बेंचमार्क. वो हमने अभी तो एड्रेस किया था. वी टोल्ड यू के ये 5.67 इट्स नॉट रिप्रेजेंटेटिव बट इट इज अ बेंचमार्क. तो सिमिलरली यू कैन हैव अ बेंचमार्क, यू कैन हैव समथिंग व्हिच इज representative but it is not a benchmark. यानी benchmark is a standard of comparison.
So in this whole data, what will be the benchmark, sir?
Well, you see,
representative, sorry.
इसमें तो representative हमने कहा कि ये देखो 6 and 7 are both representatives. यहाँ पे नहीं, actually 5 and 7. You see, अब अगर हम इसको स्टडी करें, बाइमोडल डिस्ट्रीब्यूशन में नॉर्मली ये होता है कि देयर आर 2 types of things, 2 types of populations which are being mixed in. For example, if you look at the heights of men and women, the women's heights are about 2 inches shorter. So if you look at the population as a whole, so there will be 2 modes. One will be the mode which is the most frequent height for women, and one will be the mode which is the most frequent height for men. और अगर इन सब दोनों चीज़ों को मिक्स कर दो जैसे कि पॉपुलेशन में, तो फिर the mean value will occur in the middle of those 2 modes. Just like here, yani the mean value is 6 here around, yani the median will be around 6. Okay, it separates, but it's not representative because it doesn't represent either the men or the women. But it is a benchmark, yani in the sense ke as a standard of comparison, big family kya hai? Something that is more than 6, and small family kya hai? Less than 6. This is a standard for comparison. It's fine. Works fine, but if you say it's representative, it doesn't work well. So, okay, any other issues about mood? So, यहाँ पे actually, when you talk about representative, so you have to say that there are 2 populations, and there's one representative for the large families and one representative for the small families. And actually you can run correlations, and we have done. तो इसमें ये पता चलता है कि basically poor people have larger families and rich people have smaller families. So you can also say that maybe this has to do with income. We don't know. Actually, the issue of causality, this is one of the crucial issues. Okay, what causes? And is it that people who have large families become poor because they have large families and they can't support them, or is it because people who are rich don't bother to have too many children because they don't need insurance? These are both hypotheses, and then there is a question of how we go about finding. So to go about finding, अब यहाँ पे there is a methodological issue that people are trained to just run regressions and do data analysis to find the answer, do Granger causality test, etc. This is wrong. I mean, you want to find out, you have to go into the field and look at what is happening and ask people questions and see why people have large families and why people have small families. If you go into the field and look at the real world, then you can find the answer. You cannot find it by data analysis. And it is a very important question. So, most questions are like that. In order to answer them, you have to go into the real world. So, basically, this is the modal family. Okay, so this is the question, what is the typical household size? This is what we mean when we talk about representation. Okay, we are trying to find out about, because we cannot process all of the complexity of the real data, so we want to reduce it, summarize it by one number. And so what this slide I want to say is that there is no single unique correct answer. It's very important because all of the data, all of the numbers are given. I have 127 households, all of the numbers are right there. So according to the standard Western world view, there should be an objective answer which doesn't depend on the person who is doing the calculation, the purpose for which he is doing. To any serious question there should be an objective answer which is universally agreed to all and can be used for all purposes. But this is not true. Depending on who is talking and why he is talking. So, for example, if I'm a member of the birth control commission and I want to say that the problem with Pakistan is the family size is too large, then what will I do? I will say that the average typical household size is 7. I will not explain that where I got this number, and if somebody asks where you got it, I say this is the highest, most frequently occurring value, and this is the mode. So I can defend this 7. And I say, you see, this is a very large family size and we need to reduce it. So, if I want to go a little bit better, I can say that there are 2 modes, 5 and 7. One is for the small player. And so, possibly, actually, I am saying that there is a small family and a large family, but again, this is something which requires verification. Are there really 2 types of people? Some people who like to have small families and some others.
Why cannot we round up 5.67 to 6? Would it be more?
यानी एक तो ये है कि एवरेज क्या है. Average of the data is 5.67. Now why we are writing it to 6? Only because family size is integer values. अगर rainfall data होता तो we wouldn't round it up. And rounding it up is, if we want to, it depends on what we want to do. If you want to use it as a benchmark, 5.67 is fine as it is. 6 is bigger than the average and 5 is lower than the average. So it's useful to have 5.6 as a separating value. Why not round it down? Depends on what you're trying to do with the data as to whether you round it up or round it down or use it as it is. So these are all subjective choices that you have to make. You can round it up, but then you are subject to criticism that this is not the average you are using, this is something else. By rounding, you see, you can round in many things. You can say 5.67 है तो 5-10 rounding में 5 हो जाएगा to the nearest 5 units. तो इस तरह से. Or if you say कि we are talking in units of 10, so you can round it up to 10 because it's above 5. तो rounding में तो बहुत सारी आदमी के पास इख्तियार है कि वो किस लेवल पे राउंडिंग करे. तो इसलिए so typical household size can be 7 or it can be 5 and 7, the 2 modes. Or you can say why skip over 6. So you can say typical size varies from 5 to 7, 5, 6 and 7 are all typical. So this is also okay as an answer. So all 3 answers are correct answers. And 5.56 or 5.67 will never be the right answer for typical household size almost. क्योंकि ये representation की बात कर रहे हैं यहाँ पे. Typical जो है वो representation होता है. Benchmarking के लिए it can be the right answer. So dice roll से normally होता है कि there are 6 possibilities, 1, 2, 3, 4, 5 and 6. So what is the average? What is the expected value? You must have seen this. So what is the expected value on a fair dice?
1 by 6.
हाँ?
1 by 6.
नहीं, उसके 6 possibilities होते हैं. 1, 2, 3, 4, 5, 6. ये 6 possibilities का क्या average है? 3.5, exactly. The average of these 6 numbers is 3.5. So the expected value of a dice roll is 3.5. Again, do you expect to see 3.5 dots? So this is, you cannot see 3.5. So the expected value, the average value of the dice roll can never be seen. So there is a confusion between a technical meaning and an English language meaning. अब ये जो average है, it has 2 meanings. One is average as a word in the English language, and one is average as a statistical term. And confusing these 2 creates problems, because when you talk about average, that means you take the sum of the numbers and you divide by the total number of items, and that's average. And when English average means something else, something more. So this confusion is common.
So one more question, sir.
Yes.
I hope, sir, you are not irritated.
No, this the purpose of this, and we are not lecturing here. The purpose of it is to. Actually, I shouldn't be doing so much talking. You should be asking questions.
So can we say that 5.67, if we analyze it, can we say that every third family is comprised of 6 households, while the other 2 are comprised of 5?
No, that would be true only if the family size was only 5 and 6. But we have also family size of 1, 2, 3, 4, and 9, 10, 11. So,
but on an average,
no, it's not true. Because it's not the case. Family size, the family, we have the full data here. This is the full data set, complete. So,
but that's true. But sir, if we have to divide X number of goods among people and on equitable basis, so then it will suffice the demand of that situation.
अच्छा, देखो यहाँ पे तो सब numbers हैं. इसको अगर हम if we add up all of the people and then we try to divide equally, then we'll have to put 5 in everyone and cut up a few people. Now what you are saying is another solution to the same problem. That is, we put 5 people in some of the households and 6 in others, and that way we can achieve nearly equal distribution. This is true. In that way, in that sense, if you say that, okay, what we want to do is to develop housing, and this all is one community, so what we are going to do is we are going to redistribute. There's going to be only one size house. So if there's only one size, then it has to be 5.6 rooms per house. But that won't work very well. So what we say, okay, we will have, and we can't have exact equality, but we will build houses for 5 people and build houses for 6 people. So then we need 2/3 of the houses to be size 6 and 1/3 to be size 5, and if so, then we can distribute all the people equally among these two. So that makes sense. So what you are saying is another idea about what we might want to call the average in this situation, and there are many other possibilities. So I'm saying this is a subjective question. अच्छा, ये खुद से, अच्छा, this has timing built in, so it moves. So one, अच्छा, ठीक है. Okay, so we have understood the definition of the adult definition of mode, that it is a local maximum, and there can be many modes. Bimodal is just one special case. There can be trimodal or quadrimodal. And actually, one of the important things that is not coming out here is that modes also depend on grouping. Because what happens is that modes are not useful when you have continuous data like GNP. So उसमें every value occurs only once. There is no most frequently occurring value. तो अब हम mode छोड़ देंगे? नहीं. Mode is still a useful concept, but now what you need to do is to group the data into clusters. So you can say, अच्छा, now we look at countries with income from 0 to 100, and then from 100 to 200. This is called a bin. So if we divide that data into bins, then in each bin there will be some number of countries. So now again we have, once after you do the grouping, then you will start to see modes. Before you do the grouping, there will be no mode. So now it can be bimodal or unimodal. Now the problem is that bin size will determine the mode also. If you make a very large bin, then there will be only one mode. All of the data will be inside this bin, and there will be only one mode. And the mode will be, and suppose the data varies from, like in this particular situation, the data varies from 1 to 20 or so. So if we take the actually यहाँ पे तो 11 ही आ रहे हैं, मगर that's because Attack doesn't have any very large families. At least in the random sample, there were no very large families. It might be that in Attack there are some very large families, but the random sample that we took did not get any very large families. So largest was 11. So if I divide the range into from 1 to 11, then all of the families will fall in, and there will be one mode. All other bins will be 0. So now suppose I divide it into 1, 2, 3, and then 4, 5, 6, and then 7, 8, 9. So now, depending on how I made these bins, I can change the mode. So, but still, actually, it doesn't mean that mode is useless. It means that actually you get different kinds of information. This we will study later in a different context. But the mode does convey some information, and the fact that the mode changes also conveys some information. So depending on the bin size, if the mode remains the same at all bin sizes, then that is meaningful. And if there are new modes which come in at small bin size, that's also a useful information. And all of these informations are.
सर जो हमने पीछे डिसाइड किया है कि जो है हमारे पास 7 जो है वो मोड है और 5 जो है ना वो मोड है, तो सर हम ये नहीं कह सकते कि 6 भी मोड है.
There's a definition of mode. That's very important to understand. We have a definition. It's a mathematical definition. Actually, this is the slide, and this is the same thing. Mode is defined as a value which is a local maximum. It is larger than the neighboring bins. So 6 is not larger than the neighboring bin, so 6 is not a mode. 5 is a mode because 5 is the value at 5, which is 22 families, is bigger than 14 and 17, which are the neighboring bins. 7 is a mode because again 6 and 8 have smaller numbers. 6 is not a mode because both of the neighboring bins are larger than it. ठीक है. Okay, so there are the average and the mean. These are used in the same ways, but actually average चूँकि English language term है, तो इसलिए when you want to distinguish, you want to clarify that you are using the statistical meaning. So then mean is often used as the technical term. The mean value is not so commonly used in English language, so it causes less confusion. This is actually a common rhetorical strategy, how to make arguments. When you
So can you explain this point? ये जो है कि सर एवरेज का जो मीनिंग हम इंग्लिश में देते हैं, it represents simply sir I'm not clear point कि सर इंग्लिश से और टेक्निकली इसको हम डिफरेंशिएट कैसे करें?
देखो एक्सपेक्टेड वैल्यू होता है कॉन्सेप्ट एक, तो एक्सपेक्टेड वैल्यू हैज एन इंग्लिश मीनिंग समथिंग यू एक्सपेक्ट टू सी. तो यहाँ पे भी under certain conditions I can say that the expected value of the family size is 5.57. So it's true in a technical sense, but no one would expect to see a family of 5.57. So you would be very surprised if that happened. It's hardly something that you expect. So the same thing is to average means average, normal, nothing surprising, blah. So if you see a family which has 5.57 malcolm, would you say, oh, this is average? Of course not. It's very unexpected, very surprising, very different from what you might expect to see. So I was saying that this is a rhetorical tactic. You use a technical term in the English language and then you can use it to make arguments which are actually unsound. Like, for example, if I say that the average income in Faisalabad is 25,000 because there is a huge outlier, and so people are very well off in Faisalabad relative to other cities. So this is a completely false argument, and I am relying on confusion. Yani, what I am saying is technically true. Average income is 20,000 because, or 25,000 because the millionaire has pulled up the average income. But I am also using it in the English language sense to say that it's average, meaning that most people have that amount. And so the technical meaning of the sentence is true, but the English language meaning of the sentence is false. And by confusing these two, I am creating a false and misleading impression. And this is not something which is unusual, actually. This is a great battle which has been going on over the past 30 years or so. People are saying average income of the world has been increasing, so we have made tremendous progress and economic growth has happened and wonderful things are happening. If you look a little bit beneath the number, you find that all of the gains are going to the top 1% and the bottom 99% is staying the same or sometimes even declining. In the worse African countries, their income has been going down. So the poorest of the poor are actually getting worse off. So if you say the average is going up, mathematically that's true, but if in the English language sense it is not true, because if you think about the average as being representative, then the vast majority of the population has not been improving. So again there is a conflict between what English language is saying and what technical and basically this is used to deceive people into thinking that we have prosperity, and exactly the same thing happened during the Musharraf regime, in the sense that the average GNP was increasing but the poverty was also increasing at the same time. So you could say that and he did claim for himself that I have done wonderful things for the nation because GNP has been increasing. But actually, if you look at the breakdown, if you go from the technical average to the true average in the English language, then you would find that the life of the average person has not gotten better. But it's very simple. If you think of technical, if you have all of the people have the same income, but one person is becoming very rich, then the average will keep going up, right? But the average person is not changing at all. So there is the difference between the English language average and the technical average. समझ में आ गया? Okay, so percentiles. अब ये percentiles इसमें किसी को कोई प्रॉब्लम है? Does people understand this? सर में and there is just one little point of ambiguity, which is के यानी percentile is basically the number of people that you are better than or higher than or greater than. यानी if you have score in the 99th percentile, it means that you are in the top 1% and you beat 99% of the people. There is only one small point of confusion. Should we consider that you beat your own score, or should you consider that you are equal to you beat everybody else other than yourself? तो ये दोनों possibilities correct हैं according to technicality. So if you are यानी in a class of 100, if you are the top score, then if we say that you beat everybody else, then you are at 99th percentile. If you say you include yourself, then you are at 100th percentile. So both of these are correct answers. This is the thing, and that creates confusion. अब एक मसला ये है कि Excel and all of the SPSS and Minitab, everybody has their own definition. And everybody has slightly different definitions. And chunki both of these values are correct, so somebody goes closer to the top, somebody goes closer to the bottom, and the full range is not available anywhere, so you have to do it yourself. That means that when you use computer packages to compute percentile, you will often get the wrong answer, because what happens is that what they do is they do linear interpolation. तो यहाँ पे तो वो कोई सही पॉइंट ले लेते हैं, मगर जो बीच में है एरिया, उसमें यू आर एक्चुअली ऑफ द ग्राफ, बिकॉज यू आर मेकिंग अ स्ट्रेट लाइन इंस्टेड ऑफ अ staircase. So when you make the straight line, then the percentile will be wrong, in the sense that percentile will be saying you beat 67% when you actually beat only 65, a smaller number. So that's because, so basically that's it. Yeah, there's nothing very complicated about this. So I'm showing here that household size 1, there are 4 households like that. So now the household size 1 is number 1. And if you think of sizes in reverse, actually if you size mein bada is better, to fir 1 beats nobody. If you have a household size of 1, there are no households of size 0, so you are at 0th percentile. Yeah, if you take that less than or equal to, then there are 4 households, so you beat all 4 of them. So in that case, you are at 4 out of 127, which is 3%. And similarly, at every single household size, you count the number you have, the number who are smaller than you. So at household size 2, there are 4 households which are definitely smaller, and so you are at 4 at 127, which is 3%. Or if you include less than or equal to, then there are 9 households which are of size 2, so 9 plus 4, 13. So you beat 13 households, and then you are at 13 over 127, which is about 10%. इसी तरह से ये staircase बन जाती है, and that allows you to count percentiles.
सर लास्ट टाइम भी आपने बताया था सर, थोड़ा सा दोबारा बता दीजिए सर. जो 100% जो कोई शख्स ले लेता है, या वो जो है ना नंबर 1 रैंक पे होता है, तो डिफरेंस क्या होगा उनमें?
बदला है कि in a class of 100 you have the top score, in a class of 30 you have top score. So you can say I beat 29 people, or you can say I beat all 30. It depends on whether you count less than or equal to. My score is at least as good as the score of 30 people. This is one definition. Or my score is strictly better than 29 people.
रैंक सर हमने रैंक से फिर लास्ट लेक्चर में रैंक से परसेंटाइल पे आए थे. सर हमने कहा था कि रैंक से बेहतर है परसेंटाइल को जो है ना.
सही.
तो वो मैं डिफरेंस पूछ रहा हूँ.
Oh, rank is just the number. यानी your rank is number 1 and number 2 and number 3. टाइज अगर नहीं हो, तो फिर परसेंटाइल इज रैंक आउट ऑफ टोटल, यानी 1 out of number 1 out of a class of 30 is 1 out of 30. एक्चुअली वो जो रैंक है फिर उसमें रिवर्स कर जाते हैं क्योंकि you're not at, यानी परसेंटाइल इज, यानी जो नंबर 1 है उसकी परसेंटाइल होगी, यानी ओके यू कैन कैलकुलेट द रैंक इज 1 out of 30. अब इसको परसेंटेज बना दो 1 over 30. अब इसका जो कॉम्प्लीमेंट है वो परसेंटाइल है, यानी 1 minus 1 over 30 इज द परसेंटाइल, क्योंकि परसेंटाइल में 100 परसेंटाइल जो है वो नंबर 1 को मिलता है क्योंकि ही बीट एवरीबडी. तो जो रैंक 1 out of 30 है इट्स 100 परसेंटाइल एंड इट गोज रिवर्स ऑर्डर, यानी जो 30th है पर्सन वो 30 out of 30 है, 30th out of 30 है, उसकी 0 परसेंटाइल है क्योंकि ही बीट नोबडी. तो इस तरह से बेसिकली जो परसेंटाइल है इट इज द 1 minus द रैंक ओवर द टोटल. समझ गए? नहीं समझ?
तो वो तो परसेंटाइल को कैलकुलेट करने का है ना कि n माइनस जो है वो रैंक डिवाइडेड बाय n.
हाँ, 1 minus रैंक ओवर n, एग्जैक्टली.
दैट इज ये फार्मूला है परसेंटाइल को कैलकुलेट करने का.
बिल्कुल.
लेकिन सर हमने ये बात की थी कि रैंक से बेहतर हम परसेंटाइल को यूज करते हैं.
हाँ, बिकॉज द परसेंटाइल एडजस्ट फॉर द साइज ऑफ द ग्रुप. अगर एक आदमी सेकंड है इन अ क्लास ऑफ 100 और एक आदमी फर्स्ट है इन अ क्लास ऑफ 30, तो हु इज बेटर? तो अगर रैंक देखेंगे तो वो नंबर 1 है और वो नंबर 2 है, तो नंबर 1 इज बेटर देन नंबर 2. मगर अगर हम ग्रुप साइज देखेंगे तो somebody who's ranked second in a class of size 100 is better than somebody who's top in a class of 30, क्योंकि वो जो नंबर 2 है you can think of dividing the class into 2 groups of 50. तो he is actually, और अगर हम सही से उसको डिवाइड करें तो in one group of 50 he will be at the top. So he can beat 50 people. Or if you just count by beating, then the second in the class of 100 beat 98 people in his score, and the first in class of 30 only beat 29. So in both of these ways, 2 out of 100 is better than 1 out of 30. So ये percentile जो है it automatically adjusts for the group size, makes comparison possible. Rank is not directly comparable across groups if the group size is different.
Sir, will you please tell me about the graph?
ये percentile graph?
Yes, sir.
It is just the same as the graph. यानी एक साइड पे नंबर्स हैं, दूसरी साइड पे इसका प्लॉट है. ये we start on the x-axis at 0 for any number on the x-axis. यहाँ पे if you look at the bottom, you start at the origin 0 0. This means के household size of 0. How many households have smaller than 0 household? 0%. अच्छा 1 तक ये 0 है, तो any number up to 1, यानी let's say 1/2. How many households have size smaller than 1/2? 0. How many households have household size smaller than 0.99? 0. Now, how many households have size less than 1? Now, अब यहाँ पे confusion होता है कि less than 1 तो फिर भी 0 है. Less than or equal to 1 पे there are 4. So both of these are possibilities. तो अगर हम 4 वाली ले लें तो यानी at 0 you are at 0 but also you are at 3%. तो ये पूरी जो vertical step है ये पूरी correct answer है to the asked question of how many households have smaller sizes than this one. अब जब 1 पे आ गए, जब 3% पे आ गए, तो now we go bigger. तो 1.5, how many households have size less than 1.5? So there are 4. Exactly. अब इसमें कोई confusion नहीं है, क्योंकि अगर हम 1.5 पे पूछ रहे हैं तो there are exactly 4 households less, neither more nor less. तो exactly 3%. तो यहाँ पे ये flat है. 3% remains 3% until we get to 2. जब 2 पे पहुंचते हैं तो फिर से एक एम्बिग्युइटी शुरू होती है. How many households are less than 2? Well, strictly less than 2, there are still 4, which is the same number that you had. But if you say less than or equal to, तो फिर additional 9 families come in. अब 13 over 127 हो गया. So that's 10%. So all of these values from 3% to 10%, that's at the line 2, जहाँ पे एक jump दिखला रहा है. It goes from 3% to 10%. You see 0.1 on the vertical axis. तो इसी तरह से at every step we go in the same way. आ गया समझ में?
Yes.
Okay, so now median की normal understanding यही है कि half are below and half are above. But when you have repeated values, then this is not necessarily true. ये half above, half below, it works only if you have, even in the case where you don't have repeated values. Masalan, a class consists of 10 students and they all have scores different. 10 तो थोड़ा सा complicated हो जाएगा. Let's look at 9 students. So there will be the middle student, which will be number 5. He has 4 students will be below his score and 4 will be above. So half of the class तो नहीं हुई ना. 4 out of 9 is below and 4 out of 9 is above. अब अगर उसको include कर लेंगे तो 5 out of 9, which is more than half, are below and 5 out of 9 more than half is above also. अगर उसको exclude कर देंगे तो 4 out of 9 is below and 4 out of 9 is above. तो basically जो definition of median है वो ये है कि more than half are less than or equal to and also more than half are bigger than or equal to. तो that works. तो यहाँ पे नंबर 6 जो है वो मीडियन है. 6 मीडियन है क्योंकि नंबर लेस देन इक्वल टू 6 is 61%, which is more than half, and number greater than or equal to is also 51%, which is more than half. So basically this is true only, यानी क्योंकि small sample size है, अगर बड़ा होता जाएगा तो ये मसला खत्म हो जाता है खुद ब खुद. And basically you can say that approximately it is true that about 50% of the data is below the median and 50% is above.
तो सर हमें ग्रेटर देन और लेस देन के साथ इक्वल जो है ना वो यूज करना पड़ेगा इन केस ऑफ मीडियन.
Well, in large data sets it doesn't matter, and both of them give roughly the same result. In small data sets हाँ थोड़ा सा केयरफुल होना पड़ता है. So these are the 3 most common methods. One is the mean, which is the most commonly used and the least useful. It's the least useful because it's very sensitive to outliers. Both mode and median are not sensitive to outliers. Hey, na? Why isn't the mode sensitive to outliers? Median का तो हमें मीडियन तो समझ में आ गया ना. मीडियन में अगर चलते हैं तो एक डेटा लें, उसको आउटलायर बना दें, कोई फर्क नहीं पड़ेगा मीडियन में. यानी यू कैन मूव दैट लार्ज नंबर टू इन्फिनिटी एंड स्टिल वोंट काउंट, क्योंकि यू आर जस्ट काउंटिंग कि कितने ऊपर है कितने नीचे हैं, तो वो फर्क नहीं पड़ता अगर नंबर बहुत बड़े हो जाएं. Similarly, for the mode, the most frequent value, once you have the most frequent value at 7, if the biggest household size is 1 million, still it will not change the mode. So mode is also not sensitive to outliers. What I want to show here is that outliers के लिए तो basically mode or median resistance है, mean जो है it's not, and it is the most commonly used value. So that means that quite often the मीन इज अ डिसेप्टिव मेजर. अब हम मसलन GNP पर कैपिटा लेते हैं, तो दैट इज अ डिसेप्टिव मेजर ऑफ द वेल्थ ऑफ द नेशन, बिकॉज इट गिव्स यू एन आइडिया कि अच्छा इतने, यानी फॉर एग्जाम्पल द मीन इनकम इन पाकिस्तान may be around 2,000 rupees. Now, this doesn't mean that most people are making 2,000. Actually, what happens in income distributions is that they are what is called right skewed. डिस्ट्रीब्यूशन इज सिमेट्रिक अगर दोनों तरफ बराबर हो. इनकम डिस्ट्रीब्यूशन आर नॉट नॉर्मली सिमेट्रिक. नॉट नॉर्मली द केस के ज्यादातर लोगों की वैल्यू 2000 है, फिर कुछ है जिनकी थोड़ी सी ज्यादा है 3000 में, कुछ की थोड़ी सी कम है 1000. दिस वुड बी अ सिमेट्रिक डिस्ट्रीब्यूशन. इफ 2000 इज द मीन, देन इफ मोस्ट पीपल आर एट 2000 and a few are at 3,000 and an even smaller number are 4,000, and similarly on the other side 1,000 and less are equal, so फिर तो that's a symmetric distribution. In symmetric distributions, average and mean, they are good. और normal distribution symmetric होता है. And mindset of statisticians is that everything is normal. So when you use that mindset, then you say कि ठीक है, we should use this mean, when in fact the truth is कि most of the data is not normal. तो अब skew उस साइड पे कहते हैं जिस साइड पे थोड़े extreme observations हों. तो अब in a income distribution there cannot be a left skew. Why not? ऐसा हो सकता है मगर पता नहीं क्यों लेफ्ट क्यों नहीं हो सकता.
लेफ्ट तो नेगेटिव,
नेगेटिव नंबर्स हैं. अलबत्ता इफ द इनकम इज वेरी हाई एंड मसलन a situation where the average income is 5,000 and there are very few rich people and then there are a lot of very poor people, तो इसमें not a lot of poor people, a very small number of extremely poor people, तो फिर वो लेफ्ट स्क्यू हो जाएगा. मगर that's not usually the case. What usually happens is that average is quite low and then there are a small number of very rich people. ऐसे if you remember the GNP per capita data, तो उसमें एक मुल्क है जिसकी 63,000 इनकम है और ज्यादातर की varies between 0 and 10,000 and then 10,000 to 20,000. और ये 60,000 आउटलायर इन द सेंस कि उसका नेक्स्ट कंट्री जो है 40,000 है, उसके बाद फिर एवरीथिंग इज बिटवीन 0 and 40,000 and there's one outlier at 60,000. तो ये दिस इज व्हाट्स कॉल्ड अ राइट स्क्यू. राइट मीन्स यानी इफ यू थिंक अबाउट द नंबर लाइन, तो राइट इज बिग वैल्यूज एंड लेफ्ट इज स्मॉल वैल्यूज. नाउ व्हाट काइंड ऑफ so basically in a right skew distribution, what will happen to the mean? Mean is bigger than the median. This is an important rule to remember. The mean is क्योंकि basically, as I think I'm not sure this lecture में नहीं, next lecture में है कि mean में if you just arrange the data on the axis and you try to balance it, तो वो point जहाँ पे balance करता है ना physical, तो वो बैलेंस पॉइंट इज द मीन. तो जस्ट लाइक वो जो सीसा होती है एग्जैक्टली. तो उसमें अगर कोई मोटा आदमी हो मेरे जैसा तो उसको सेंटर के करीब बिठाओ तो फिर बैलेंस कर जाता है, छोटा बच्चा दूर बैठे तो बैलेंस कर जाता है. तो इसी तरह से डेटा में अगर कोई आउटलायर है तो वो जो बैलेंस पॉइंट है वो आउटलायर की तरफ पुल हो जाएगा. मगर इफ यू जस्ट कंसिडर कटिंग द डेटा इनटू हाफ के आधा इधर आधा इधर, तो वो पुल नहीं होगा. तो दैट मीन्स द मीन विल बी पुल्ड to the right, median will remain where it is. So mean will be bigger than the median in a right skew. In a left skew, the opposite will happen. Yani mean will be less than the median. So this is one way to detect the skew. अच्छा, तो इसके मानी चूंकि practically speaking, empirically, in income distributions we have right skew, so mean is bigger than the median. So if somebody wants to make a case that Pakistan is progressing and is a rich country, he should use the mean. If somebody wants to the case that awam ki halat kharab hai, so then he needs to talk about the median. And perhaps even better, the mode will be even smaller than the median. Because if you look at a distribution, so mode jo hai, and mode might be actually a more useful measure in this case. Yani if you are trying to talk about the lives of the people, and look at the group which has the most number of people in it, that makes sense. That's the modal group. Median jo hai wo half and half, wo ek tarah se usme bhi ek sense hai, magar it's not so representative actually. The mode would be the more representative. आम आदमी की क्या हालत है, तो वो हम उस तरह से देखेंगे कि वो कौन सा ग्रुप है जो मोस्ट फ्रीक्वेंट है. और अगर हम यानी वो मीडियन जो है, इट्स हैज नॉन प्रॉपर्टी, मीन इज द वर्स्ट, इज द मोस्ट एग्जैजरेटेड. तो कौन सा इस्तेमाल करना है, डिपेंड ऑन व्हाट आर्ग्यूमेंट यू आर मेकिंग, हु यू आर, व्हाई यू आर यूजिंग दिस. अब तुम पॉलिटिकल पार्टी में हो और तुम्हारी पार्टी पावर में है, तो यू शुड बी टॉकिंग अबाउट द मीन. If you are in the opposition party, you should be talking about the mode. सही है ना? तो the mean is very bad with outliers. अब ये एक मैंने simple सा example दिया है कि ये population है countries का. इसमें Nigeria is a very big country with 146 million people. और बाकी सबके छोटे छोटे numbers हैं. कतर बहुत छोटे हैं. अब इन सब का हमने average लिया, तो average population of these countries is 22 million. अभी 22 million जो है, it's nowhere, यानी it doesn't do anything. अगर it doesn't represent anything, क्योंकि it's यानी it's the average of one outlier and another group. तो जो छोटे ममालिक हैं 12 million and less, they are not represented by 22 million. And Nigeria has nothing to do with 22 million. So nobody is being represented here. और बात ये भी है कि it's not necessarily true that there is always a representative. Yani, if there is a lot of diversity, then even the attempt to represent is a mistake. You should say that there is very diverse kinds of experience, and there is no point in talking about an average or a representative. ये बात उस वक्त समझ में आती है जब हम ये डीलिंक करते हैं कि फैक्ट्स फ्रॉम, यानी कि नाउ वी आर टॉकिंग अबाउट, यानी स्टैटिस्टिक्स इज अ वे ऑफ टॉकिंग विद नंबर्स बट एंड डिस्क्राइबिंग थिंग्स, बट समटाइम्स नंबर्स कैन नॉट बी यूज्ड टू डिस्क्राइब, समटाइम्स द इंफॉर्मेशन इज क्वालिटेटिव. तो जस्ट टेकिंग एनी सेट ऑफ नंबर्स एंड प्रोड्यूसिंग द एवरेज डजंट नेसेसरली लीड टू सम मीनिंगफुल number. The average is meaningful only in some situations and not in others. So यहाँ पे it's not representative, and I've said it's not a benchmark, but actually it could be a benchmark, and it depends. And you can say कि अच्छा, big population countries are above 22 million, so Nigeria is big, and anything less than 22 million is a small country, so all others are small. So in that case, it's perfectly fine as a benchmark, as a standard for comparison. तो जब मैंने यहाँ पे स्लाइड में लिखा है कि mean is not a benchmark, what I had in mind is कि most of the population is the small countries. एक outlier आ गया है जो exceptional है. So if we want to talk about benchmarking and representing that big population, तो फिर the mean is not a benchmark for the remaining countries. अब जो रिमेनिंग कंट्रीज उसमें हम मीडियन ले ले तो हम कहेंगे कि ये बिग कंट्री है रिलेटिव टू दीज 6 कंट्रीज और ये स्मॉल कंट्री है, तो उसमें मीडियन जो है इट विल वर्क मच बेटर. दिस इज अगेन अ राइट स्क्यूड डिस्ट्रीब्यूशन. इसमें अगर 6 ममालिक बड़े बड़े होते और एक छोटा सा होता तो वो लेफ्ट स्क्यू हो जाता। यहाँ पे हो सकता है आसानी से कि हम ब्रुनाई डाल दें और फिर सारे बड़े ममालिक जाए जिसमें मिलियंस हैं, तो फिर ब्रुनाई विल बी लेफ्ट स्क्यू, इट्स विल बी आउटलायर इन द लेफ्ट डायरेक्शन एंड इट विल पुल द एवरेज डाउन। अब ये की कॉन्सेप्ट है स्टेटिस्टिक्स की कि रैंडम सैम्पलिंग। जैसे बेसिकली इन स्टेटिस्टिक्स व्हाट हैपेंस इज दैट वी डोंट हैव एक्सेस टू द फुल डेटा। हम पॉपुलेशन ऑफ पाकिस्तान को हम स्टडी करना चाहते हैं, तो वी कैनॉट गो एंड आस्क टेक अ सर्वे फ्रॉम ऑल ऑफ द मिलियंस एंड मिलियंस ऑफ पीपल। इट्स जस्ट not feasible, too expensive, etc., etc., etc. So what we do is we take a random sample, or we take a sample of convenience. That's more common. कि जो हाथ आया, मसलन you want to go and sample customer satisfaction in Islamic banks, as some people did. तो वो जाके वहां पे लॉबी में खड़े हो गए और जो भी हाथ आया उसको कहा कि ये क्वेश्चनर फिल करना है। तो some people were in a hurry and they didn't, some people were not, so they did. तो अब this is called a sample of convenience. This is what जो हाथ आ रहा है. Is this sample representative? Almost surely not. तो random sample has, it's also called a probability sample. Random sampling के लिए जी.
Sir, why not? Because all those who are visiting the bank, they are the customers. And
yes.
We are just trying to know their level of satisfaction.
देखो, यानी actually this is an empirical question. यानी it happens that देखो एक पोलियो की स्टडी हुई थी. This thing happens quite often. एक पोलियो की स्टडी हुई थी in which what they did was that they offered the polio vaccine to students. At that time the polio vaccine was new and experimental, so they didn't know. तो उन्होंने कहा कि एक बड़े स्केल पे एक स्टडी की कि does it work to prevent polio or not. This was long time ago. तो उन्होंने क्या किया कि they said कि अच्छा whoever wants to take the vaccine can take it, और वो हमारा ग्रुप होगा. It's a sample of convenience, and what one needed to do was to randomly divide the group into two and then give the vaccine to one half and not give it to the other half. So random division में equality हो जाती है, both sides are representative. Instead of random sampling, what they did was they said कि whoever wants to take the vaccine can take it, and whoever doesn't want to doesn't need to take it, and then we will compare. तो अब हुआ ये कि there was a strong bias in this experiment because of two factors. एक फैक्टर ये था कि the population polio is an unusual disease in the sense that unlike most diseases it hits the rich more than it hits the poor. क्योंकि होता है कि it's a disease of sanitation. जो लोग unsanitary conditions में रहते हैं, they are exposed to polio and they develop immunity. जो लोग बहुत ज्यादा सफाई सुथराई करते हैं, तो they are not exposed to this germ and they don't have immunity, so they are more likely to catch polio. तो ये एक फैक्टर था. तो दूसरा फैक्टर था वो ये था कि rich people were less suspicious of vaccines and poor people are very suspicious of experiments. तो जिन लोगों ने वॉलंटियर किया कि yes we will accept the polio vaccine, they were from the richer classes, and in the poorer classes in the USA the people did not accept, did not volunteer. तो अब ये डबल बायस हो गया कि जिन लोगों को ससेप्टेबल थे उनको वैक्सीन मिली और जो लोग नहीं थे उनको नहीं दी गई. तो अब ऑल ऑफ दीज बायसेस वर इंट्रोड्यूस्ड, रिजल्ट जो है वो थोड़ी सी सही नहीं आई. तो एनीवे देयर वाज एनफ ऑफ अ डिफरेंस कि फिर भी पता चल गया कि इट्स अ गुड वैक्सीन. बट इसी तरह से बहुत सारे एक्सपेरिमेंट्स हुए, जैसे डॉक्टर्स के एक्सपेरिमेंट्स हुए ऑन फाइंडिंग आउट whether this surgery is useful or not. bypass surgery हो रही है और भी बहुत सी किस्म की shunt surgery थी. तो what the surgeons did was they said कि अच्छा, for our surgery we will pick those people who are in the best condition, क्योंकि we don't want complications के उसका एक आदमी है उसका यानी से उसका कोई लिवर बाईपास करना है तो उसका लिवर खराब है मगर उसके और भी बहुत से कॉम्प्लिकेशंस हैं तो उसको हम नहीं ऑपरेट करेंगे. एक है उसका सिर्फ लिवर खराब है और कोई कॉम्प्लिकेशन है उसको हम ऑपरेट कर देंगे. तो 10 people who were left had not only the problem but also many other problems, and those who were operated were those who did not have any complications, so they were healthier. तो अब they concluded कि देखो हमारे जो सर्जिकल पेशेंट्स हैं they all lived longer क्योंकि they were healthier to begin with, and those people who were not operated they didn't live long enough. So that was a sample of convenience for the surgeons क्योंकि they didn't want their surgery to be messed up by additional complications. But the result was कि the conclusion from the experiment was कि the surgery is very helpful when in fact it was not. और जब वो large scale पे की गई तो it was found out कि it doesn't help, actually it's harmful. फिर उसको रिवर्स कर दिया गया. इस तरह से बहुत सारे एक्सपेरिमेंट्स हुए हैं जिसमें because of non-random sampling the persons, for example consider your Islamic bank case. You're standing in the lobby, you're asking the person. तो एक आदमी है जो बहुत बिजी है, बहुत रिच है, वो तो कभी नहीं रुकने वाला. जो आदमी आपके पास बैठ के आधा घंटा आपका सर्वे भरेगा वो जरा फारिग है, उसके अनएम्प्लॉयड है, तो you're going to get a strong bias. You're going to say अच्छा, all of my people are low income unemployed people who are filling out the survey. It's not a representative sample. Sample of convenience is not representative. तो representative sample लेने के लिए what you have to do is you have to have first of all a list of all of the people, and then you have to have a randomization mechanism which every single person must have exactly equal chance. ये नहीं है कि आंखें बंद करके हमने पॉइंट कर दिया क्योंकि that way we don't know कि what the chance was. We have to make sure कि number one अगर 100 लोग हैं तो person number one must have 1/100 chance of being chosen. There are ways to do this. So basically issue ये है कि if you do a random sample then you can prove mathematically कि the random sample will be similar to the population. अब वो exact similarity क्या होगी, कितना variation हो सकता है, these are all important parts of statistics जिसके लिए हमारे पास formulas हैं कि कितना बड़ा sample चाहिए, कितनी accuracy के लिए, इस सब के यानी these are all things which are subject to analysis. मगर if you have a non-random sample which is typical, then there is nothing, there is no control, it can go any which way. Okay, I think तो बेसिकली वी स्टडी द सैंपल्स टू फाइंड आउट अबाउट द पॉपुलेशन. अगर रैंडम सैंपल है तब तो इट्स पॉसिबल टू डू, अगर नहीं है तो फिर इट्स नॉट पॉसिबल टू डू. मगर व्हाट हैपेंस मोस्ट ऑफन इन रियल वर्ल्ड इज कि यू टेक अ नॉन रैंडम सैंपल एंड यू प्रिटेंड इट्स अ रैंडम सैंपल एंड यूज द सेम फार्मूलाज एंड दीज आर रॉन्ग, दे डोंट वर्क. ठीक है, आई थिंक दैट्स इट. सुभान अल्लाह.